This is going to be a very, very high interest to anyone who feels like correcting pi. I don't know again if that's useful there because I've never used that before. Let me see again if this is. Can I? Yeah, I can do that. Nice job. So that here and that there, you need to get to check it out. That's like the most important part of it all. It's like I don't know exactly how to explain it, but the pi that y'all been using for a very long time is wrong. That one here, it's wrong. You know, it's never going to be any right ever. And the reason why I'm going to show you here, um, as you can see, there's a 3143455, and this is associated with this here 3141593. Now the 3141593 is incorrect. First off, there's no equations to get to know exactly where the fuck it came from. Second of, it has no balance whatsoever. Third of, it's not relating to what's the name again, to the golden ratio at all. And just in case, okay, that you were asking yourselves, okay, why you're looking at a triangle, it's because that triangle is a Kepler's right triangle, and it was based on a template made by Pythagoras. You know, the Pythagorean theorem. I can't even pronounce this. And anyways, so here's an exercise, okay, which I have done for myself personally, and I do hope, okay, that I can share this to everyone throughout the whole of this planet. And that's like ultimate proof. Like anything, okay, that can be done on paper can be done on paper, okay, but a calculator, okay, never fails. One thing, okay, that I've noticed, okay, is that squares, polygons like triangles or pentagons, hexagons, they will always, 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 and I'll have to repeat that again, always give you the exact answer. Always. It's only the circle, okay, for some odd reason, okay, it doesn't give you the right answer. And the reason why it doesn't give you the right answer is namely because of that. Let me show you again. That number here, pi, which is the fake pi. And of course, a whole lot of people out there, they be like, oh, why are you saying it's a fake pi, man? Nah, man, this ain't a fake pi, man. We've been using it again for thousands of years, man. That's the best pi we've ever had. Nah, man, it's not the best pi. It never was, never will be. And the main reason why it never will be is because of that. Because it does not relate to the golden ratio. You're probably wondering why there's a 3.143455. It's namely because that's like the length of the golden ratio for that number. Yeah. So that triangle, just because of that number, which is called I don't even know how to call this. It's wrong. Yeah. It's not pi. There's no name for it. Yeah. It doesn't equate to no pyramid whatsoever. Now, that being said, let me show you something very interesting. Let's say that we're changing this here by the pi that the one of the previous pi's. Like let's say for example, 22 divided by 7 gives you the 31428. You would hope that maybe it is the correct pi. It's not. It really ain't. Let me show you why. Here, you see 3142857, and the number which was 31435 changed to 31439. Weird, isn't it? The more you increase on the one below, the more it increase on the one on the hypotenuse. The one which is below is known as the opposite. The one where you see the green fake pi there, that's one part of the hypotenuse. Okay, but as you can see, it changes to the point that you can even see that the angle, it changed also. Before, okay, it wasn't 5184, it was something else. I can put it back again, okay, so that in this way you can see exactly what I'm talking about. All right, so I put pi, then I do okay, and you see 5185. The previous one was 5184, and on the side okay, of the hypotenuse, 3.143455 instead of the 3.1439 which we saw a few moments ago. Now, that being said, let me show you the correct pi. And the correct pi, which is based upon the golden ratio. And so to get the golden ratio, you would have to do 1 plus the square root of 5 divided by 2. That's a golden ratio, 1.618034. I'm just going to abbreviate it to 0.34. I don't want to expound to it. But to get 2d pi, we need to get like the square root of the golden ratio, which is this. And we're going to divide this number, we're going to do 1 divided by that number, which gives us certain harmonic. I don't even remember okay, what this is, okay, but this is very important. You can find the importance okay, of this number when you would use it either as a sine or a cosine. I don't remember which one, but it gives you a degree, and the degree okay, is going to be shown in a few seconds. And then you multiply that number by 4. Voila, this is d pi. And how do we know it is d pi? There. Do you see this here and that here are exactly the same? The degree here, 5182, as it's supposed to be for a pyramid. Then there's the degree here, 3817, which is correct as well. You know, it doesn't take like a math genius to figure out okay, that this is the correct one. I mean, like, seriously, you really don't need to be like a math genius to figure out that this is the correct one. So that being said, if ever like there are any scientists out there who are seeing this video and they were asking themselves okay, why they had so many mistakes, like marginal mistakes done okay, like in orbital stuff, or maybe engineers trying okay, to create stuff but they weren't able to okay, because the number okay, was not coherent, something like that. I was namely because the pi okay, that you was using, that one was wrong, and it brought like imbalance throughout the whole of your equation. So I'm just going to put back the number again, and just do that. Yeah, there we go. And that's it. Thank you for listening. Thank you for watching. I do hope okay, that this was very informative, and I do hope okay, that you do your research as well. This is 9 Prime. Peace.